Okay, hey, train your plants every day. Jordan Scoville coming at you from the STEM Lab, my personal Hydron Collider up in this Bizitch. Okay, so this is the Blue Monster, and let's take a crash course in a master's crash course in masonry here. While dealing with the quantum mechanics and STEM in particular, I say that this is my Hadron Collider, and it really is. We have a lot of things that go on in here that have the basis of particles. This whole palette right here, a beautiful 18 5-footers, gorgeous, personal handmade. 12 4-footers, 12 3-footers, stacks of stuff over here. All of these are individual particles. Okay, so yourself, you're a particle. This is the field. Okay, so you're looking at these things as if they're whole elements that have weights and masses, and I can determine their momentum or I can determine their position. You can base timelines, you can base quotes in terms of those ideas. You can do things like reverse time symmetry, which is fun. Notam's theorem. So you got a stack over here, and why no palette that you need palette off of stack that should quote? Well, not knowing the variable that this wave can pass through both of those slits at the same time says this stack has a given mass, that this has a given yield. Well, you may not know what it is yet. We have to work it, we have to thermal it, and then we'll have to cut it, and then we'll have to do the edges on it. And there's a lot of variable in that says it may or may not do. And we're using basically X-ray vision here. We're using the X-ray spectrum to grade these rocks. We're applying physics to kind of calculate those things. When you get to this first one, it makes that calculation real easy. They're based in physics. This is an observable universe and based how the rules work here. All right, obviously this is a particle as well, and therefore I might not know its exact momentum or position while dealing with customers, rock coming in the door, all kinds of other variables that dictate a lot of the new term Albin Heinrich's work does work, but he Rhodes conjecture, an abruptly long sequence of reciprocating terms based off of a sequence of Fermat's theorem AX, BX equals CX, or to the Beal's conjecture of the Millennium Problems, AX plus BY equals CZ. Pretty simple algebra, really, when you think about it, but it has a lot to do with quantum mechanics in the holographic spectrum of this essentially is a black hole, that's a black hole. These, dumpsters can go critical mass on you in a heartbeat if you're not careful. A thermonuclear runoff can happen like that. And the fallout is a term base that can have definitions by these models that play very similar and parallel in these universes. But hypothetically, we could observe this to have from there to here essentially a black hole system where the conservation of information, black holes seem to defy this logic. But knowing reverse time symmetry and some of the nature of particle physics into these ideas certainly gives you some great insight, some great physics, some new terms to idealize these principles in a STEM mechanics system: science, technology, engineering, and mathematics. As it stands, we know that there's a tutorial base, that A is thermaling bluestone, A is working the saw, and there is no difference between that particle A as you look at it on a note breakdown. Okay, that's a point with an A. It's 1, it's 2, it's 0, it's 1. It's in all of those places simultaneously based off its general. This is where it becomes a particle. This is where the electron, that if you like Feynman's technique, says it's one electron across the board, it's all of them, but time-space says it applies here now. You're as much of this particle as anything else, and you need to be aware of that. But reverse time symmetry can help you do things. If you're looking at a palette, if you're looking at your business, any business will do. I'm not particular. But you see chips. Then you can base reverse time symmetry. Where in this process of laws that base physics to exact numbers and exact calculation did things go awry? that the idea that the problem becomes when there was more variables or more field or more space than this rigid structure of absolute zero, where those particles obey an electromagnetic field perfectly, that I know the exact momentum and position of those things. Well, given the field idea again, that the field dictates certain momentum, is a particle on its own thing, is an element and by itself to this idea. Here, not carbon, not hydrogen, not gold, nothing along those lines, but in a stem mechanics system, in masonry and stone, in master fields, in this larger principle. Now you could look at those ideas and say, hey, it's chipping over there. You know, I see it in the process here. It's either off the table when I'm unloading them first thing in the morning, or it's somewhere along the process here, depending on which variable of those they come in. Here, you just see a pallet. You may not know where that thing comes from, so you have to do things. I'm looking in the dumpster. I see big scrag. That means that obviously I cut big slabs last night or cut tread cakes. So I'm basing some of the physics of other particles in the world around me that dictate some gravity into this situation in this observable universe. Black holes have temperature variations that say, I don't know whether it is, what information it was. All it's left is Hawking radiation based in a thermodynamic principle. It gives off heat. I don't know what it is. Too much information, too many stars falling into it, too many things, too many variables that say from this idea. But here we get to close it off a little bit, just like that black hole. Now, black holes have a lot of stuff going on. Here, the variables are much more closed off. Now, again, we still have a lot of those variables. This applies by some black hole, all black holes, any and everything. But in this observable universe based in general relativity, things are closed off a little bit better. And we base rules in those principles. We say that there's ideas, ways, general ground law haven ways to those ideas, and the fifth dimensional calculation of the Planck spectrum ideas to this being as much a photon, a living element, as anything else. If an element can't have the idea of free will, to have this idea that it has unknowable momentum and position at the same time, I can't truly look at it as if it is just a raw element that is unabidable to any other standard. They all die, they all decay, they all have principles under those ideas. Photons move from this spot to some other space, saying that the mass of it here at this point in time is 1, and then in the next 0. So these are some of the ideas that you can kind of come up with. Obviously, you can have fun with power series in here in mathematics. You can air turbulence equation this. You can see patterns based in Riemann hypothesis. They're all ones. This is an A. This is a 2. There's a lot of fun stuff you can do with this stuff if you're willing to study it. A lot of parapsychology, quantum mechanics happens here every day, as much as standard physics, as much as standard operating procedures, economics, management, safety systems. All of those are great skills, but don't forget your other line information, that there's a lot here in everyday job, whether it be McDonald's, whether it be your Stone Dock, or anywhere else, that this could be your potential hadron collider as a physicist, as a particle physicist. There's great opportunity here for a psychologist to see frames of reference, to see marshmallow experiments being made, to see any form of those ideas with staff and yourself and a bunch of other things. So, short brief note on the master's class, the masonry. Catch you on the next one.